Oh, now I'm live. Great. I missed all that. All right. I just talked about this to the whole class. So those of you online, pause it, read it. Hope you get it. All right. So the probability that there are 9 or fewer out of 31 teachers, given that 76 is what's expected, 76%, is 0.0000000449. Right? That's pretty close to nothing. I mean, it should be rare that that happens. So one of two things happen. This is just a really weird group of teachers, or maybe something was wrong with my random selection. Oh, could something have been wrong with my random? Where did I get these numbers anyway? No, I went to the Pendleton Public Schools website and I picked the middle school. And at the middle school, there are 31 teachers, 9 of which are female. Was that a random enough selection, or maybe that was a little biased for some reason? Maybe some reason the middle school ends up with male teachers because there's a lot of reasons why, I don't know.
You don't want to do it with their clothes.
Like when I first came to Pendleton, I don't know if this is a guy thing, I drove into town and thinking 1 year max, I'm out of here, right? I've been here, this is I think my 18th year, 19th year, something like that. All right, so it's been a long year. Okay, so this is a situation where 9 out of 31 is unusually low if I'm expecting 76%, which means 23 or 24 of them. Okay, so that's unusually low. The other problem is an unusually large probability, maybe. So let's look at the other problem. Next question, number 2. Oops, wrong magic pen. Number 2 was same initial information given that 76% of public school teachers are female, Is it unusual to find 12 out of 12 female teachers? Okay, there's one of two things you should do with this question first. Can somebody tell me? First thing I should probably do here? What's that? No, not use the PDF. I should find out what is the mean, what is expected in this situation. I expect 76%. What is 76% of 12? That's what the mean is, the expected value. 0.76 times 12. Somebody give me a number. 9.12. Okay, so let's say we're just going to round that to 9. I expect out of a randomly chosen group of 12 teachers that about 9 of them will be female, if it's true that on average 76% are female. That's what I expect to have happen. Okay. What did I find? I found that 12 out of 12, which is 100%, are female. Female. Okay. Would you agree that's higher than what's expected? Okay. So then the big question is it unusually high, or is it just a little high? Because can't some things just be a little bit high? Right? Can't they? Average grade on the test is 70. I got a 71. I scored higher. Is that significantly higher? Okay. Right? So sometimes things are higher, not a big deal. Sometimes things are higher, and it is a big deal. So is this being high unusual? Okay. So next question. Is it unusually high? Usually high. So just for fun, I drew the distribution. So let me snap that in here just to look at it. Here's the distribution for 12 people. What's the probability that blank out of 12 is going to be female? So that's what it looks like. What's the highest stack on this distribution? Can you see what number is the highest stack? 9. What's the mean? 9. Yeah, the mean is going to be the highest stack in the binomial distribution. Okay, so that's important. I want to calculate what here? I want to, oops, wrong button. The probability that X is greater than or equal to 12. Because to talk about unusual events, you have to do a tail. But wait, how many numbers are in this tail? One number, right? 12 is the highest number. Yeah, so it turns out, usually when we do tails, we do CDFs, but in this case, there's only one number in the tail, so I can get by with a PDF. So here a PDF will work. So then I'm going to calculate the binomial PDF. Oops, that's a P. What numbers am I going to plug in here? N is 12, P is 0.76, and X is 12. Okay, anybody calculate that probability? Okay, so I might tell my mother it's about 4%. What's our cutoff for unusual events? 5%. Is this less than 5%? Less than 5%. That's true. That's an exclamation point, not a factorial. So can I then conclude that finding 12 out of 12 females is unusually high if I expect 76%? Yes, that is what we just discovered here. 12 out of 12 females is unusually high. Unusually high what? Number of people or probability? Number of people. Unusual events are always about the things you're looking at. So I'm running out of room for that. Let me put it on the next page. My conclusion is that 12 out of 12 females is an unusually high number of females. Questions? It's the way it ended up. I looked at it. What's N here? What's N here? Seriously? 12. What's X here? 12, so they are the tail. What if the situation, let's look at it different. Suppose I sampled 50 people, and I found that X was equal to 47. Oops, there we go, 47. Is 47 out of 50 an unusually high number of female teachers to be found in a school, if 76 is what's expected? Okay, well, that distribution would look like the other ones. It's going to be skewed to the left. Tail is the skew. Okay, I would expect to find 50% of 76, which is what, 38-ish? 38? I would expect to find 38. I'm over here at 47. To figure out if that's unusual, I need to calculate that whole tail. Is that a PDF or a CDF problem? It's a CDF problem. Now, there's a problem though. CDF calculates what? Left or right tails? Left tails. Okay. So to do this particular probability right here, I would have to calculate this left tail here and then do 1 minus the left tail to get my right tail. So now I want everyone to see if they can come up with a number on this third situation. And then we got to move on to normal distributions. Is 47 out of 50 an unusually high number of females? It is if the tail probability is small. How small? What's our marker for small? 5%, 0.05, careful. Yeah. Are we always going to use 5%? Answer is no. Sometimes we'll use 1%. Depends on the situation. Okay, so I'm going to write down what I would type, and then I'm going to type it. On a test, you are going to write for me what formula you typed. Remember I mentioned that the other day? The formula that you type on the calculator has to be written on paper. That's what you should have typed in. I want to keep the numbers 47 and above, which means I want to remove which numbers? 46 and below. If I remove the numbers, right, isn't subtraction a removal? This says remove all of the probabilities from 46 and under. That leaves 47 and above. Because I have the equal to. I want to keep 47. So that means I want to keep 47, 48, 49, and 50. This formula says subtract means remove, right? Remove probabilities for 46, 45, all the way down to 2, 1, 0. I want to remove all of their probabilities. Whatever's left has to be the right tail. That's what that formula means. Okay, what do we get? Anyone get a number? 1 minus binom 50 trials, 0.76. Variable is 46 and under. True. Ooh, GeoGebra says 0. Options, rounding, let's go 10 decimal places. Okay, I got 0.0008. You guys get that or something different? Same thing? Uh-oh, let me try it on the calculator. 1 minus, oh, you gotta have the 1 minus, otherwise it's not what we're looking for. Am I using CDF or PDF here? CDF, right? I'm removing the left tail to keep the right. 50 trials, probability of success is 0.76, X is 46. I'm removing 46 and lower. Paste. 0.0, oh, I got to, oh yeah, that's it, yeah, 0.000830. Yeah, GeoGebra and the calculator agree. 308. So this is approximately 0.1238-ish. As a percent, you shift the decimal point twice, so this would be 0.08%. 0.08 of a percent chance of this happening. Does that mean if there's an 0.08, if you are going to gamble and someone said there's an 0.08% chance you will win, would you bother wasting your time? Okay. If you were going to go do something and someone said there's an 0.08% chance you'll succeed, would you bother trying? I'm not sure I would. So, is 47 out of 50 an unusually high number of female teachers? Yes, because the probability that it happens is wicked low. Okay, so conclusion, write down a conclusion in English that my mother would like. Go for it. What is our conclusion here? Without using too technical terms. That gets the point across without twisting the truth. And there's lots of ways to word this. Mine is not necessarily the best. That's one version of the sentence. Finding 47 out of 50 female teachers is an unusually high number of females. What's our assumption the whole time that makes this unusually high? Yeah, that we were expecting to find 76%. So my mother might say, well, why is it unusually high? I still don't get it, right? Because I was expecting 76%. So if I were doing a true random sample in a school district and I randomly grabbed 50 out of like 1,000 teachers, let's take a bigger school district like Portland, and I found that in a few samples of 50, there were around 47 out of 50, I would conclude there's something weird here because you're way above the national average in hiring females. Why is that? Get what I'm saying? Like, are you biased against men? Do you think men can't teach? Or all men are like creepy and might damage young people somehow? Okay, that's enough of that. New topic. So that's chapter 5. I hope the idea of unusually high and unusually low is a tough idea. That's page 205 in the book. I hope you keep trying to get it. And